Well, welcome back, everyone. Could someone kill just the lights so we can see the board? Just not all of them. Just no. That'll work just for now. All right. So today we are going to start with a quiz. All right. And the way we're going to do this, because of how you're sitting, we're going to have the people on this side of the table. So here's a table. These two, right? Those two, those two, those two, those two, those two, those two, right? Y'all are going to be A. You're going to do problem A. The people across from you will do B. So B over there, B over there. Is that okay? Make sense? B. By yourself, you'll do A. Okay? Everyone understand? The two problems, you only do one of them. You're either A or B. So please just get out a sheet of paper. You can have a calculator. And that's it. You ready? So you're just going to copy the problem off the board and you're going to do it. All right? We are kind of in quiz mode now, okay? So let's keep it silent, please. Hold on just a second. Okay, so B is going to be okay. The instructions for these problems are as follows. Write each equation in slope-intercept form. What slope-intercept form? Good. Y equals mx plus b. Okay, so you're going to write each of the... So for people doing A, those are two equations, right? You write each one of them in slope-intercept form, okay? And then for part B, there's two equations, you do the same thing. And then determine if the lines are parallel, perpendicular, or neither. All right. Any questions on the instructions? So you should have three things boxed as answers. The first equation written in y equals mx plus b, box it. Second equation, y equals mx plus b, boxed. And then your last answer, parallel, perpendicular, neither. And you need to justify kind of why. I need to see some work. Don't just guess, oh, it's parallel. Okay? If, just FYI, these are exactly two problems, number 71 and number 72 from the homework. So if you did your homework, these are homework problems. Okay. Good luck. I'll give Okay, so today we're going to get into 2.4 and 2.5, all right? And I'm going to kind of blend the two sections together because I kind of do it in my own, not my own way, but in my own order. So I might be doing a little bit of 2.5 while I'm doing 2.4. So I'm just going to title this 2.4 and 2.5, all right? And we're going to call it functions. And we'll start off with, first of all, the idea of a function, okay? A function, can everyone see the board, or is it too bright? We need to kill a light? You want to kill a light? Can we get the middle one there? Is that all right now? Okay. Okay, a function, this is the definition, is a rule which assigns a value to each number given to the function. Another way to look at it is you have input, which is a number, goes through some function, comes out the other side as an output, and that's also a number. So you can look at a function almost like like an operator, not like an operator like you call the operator, but like you have some sort of algebraic rule. Like let's say the rule is squaring something, then it would look like this. Your input would be a number. It would come into this function. Maybe it's the function that squares, and then it comes out the other side, right? Input, output. The squaring is the function, all right? It's the rule. So if I continue with this idea, if I take the number 3, I send it through this function, squaring function, it would come out the other side as well. 9. Because when it went in, it got squared, right? That's the idea of a function. You have an input, you have an output. Now, what we want to get used to is the idea of what is the stuff that you plug in, what do we call it, and what is the stuff that comes out, what do we call that? We have names for them. So here's where we get into some more terminology. The input is called the domain of the function. Okay, domain. The output is called the range of the function. So input is domain, output is range. So that's just words now, okay? Another picture for you, and this is one of the most common pictures that you'll see for functions, is where you have the input, which is the domain, and the output over here is the range. And what happens as you go from one to the other is the function, right? So you start with the domain, it goes through the function, comes out into the range. So input, output. Now we need to get some notation established, all right? So we're going to move on to notation. Function notation. Normally when we write a function, we use the letter F. Y'all seen that before? And then we write in parentheses X. And what this means is F is the name of the function, and the X is the input. That's what we're going to put in. And then we say this equals something. And for this particular notation, I'm just going to call it Y. And the Y is then the what? What do you think? Yes, it'll be all of the Y's. So the X is what I plug in, right? The X right there goes into that function, and what comes out is the Y. So all of the X's together is domain. All of the Y's is the range. But in this particular notation, if that X represents one input, then the Y represents a single output. Okay, so this is going to be an output. Now, how would you say this if you were talking like English? Okay, how do you say this line? You'd say F of X equals Y. That's the way you say that. F of X equals Y. So that little F with the parentheses inside it, we say that F of X. Now, since F is the name of our function, we can name a function anything we want. So what would this be? How would you say this? G of X equals M, right? Or you could say something like C of T equals K. So for the G of X equals M, what's your input? Bx. And then what's your output? Bm. And then for your C of T equals K, T is the input, K is what you get out. All right? And then, you could move on. So you could actually do this. Something like that. What's the name of that function? Cost. So you'd say cost of R equals L. I just want you to get, I guess what I'm trying to illustrate to you is that functions can be called anything you want. You can call it the F function, the G. We usually use F because function, right? But it doesn't have to be F. Right, so that's our notation. Now, we need to talk about explicitly defining a function. So how to explicitly define a function. So I said earlier that in that example we had that squaring, right? We said the function would square something. Let me try and do that writing it explicitly. So I'm going to start with this example. Okay, I'm going to call it the square. I'll call it the squaring function. I want to write out a function for you that tells you to square something. So the way I write it is I'll call it F, right? I could have called it G, whatever I want. And then X is my input. Now what do I want my output to be? If I want it to square, I want my output to actually be what? Not Y squared. What are we plugging in? We're plugging in X, right? So don't I want to square that X? So I say X squared, right? So look at how this works. Your input, right? I'm just going to say in, right? Your in is the X, and what should come out? The X squared. Whatever you plug in, square it. Make sense? And we can do every function that way. We can define it explicitly. So this is the explicit definition of the squaring function. Okay, let me see if you can help me out with the next one. I want a function, okay, that what it's going to do is it's going to cube what you plug in and then add 3. So I would do f of x equals x cubed plus 3, right? That would do it. So this is just another example of a function. I'm not going to call it anything, but that explicitly defines a function. It tells you exactly what that function does, right? Takes whatever you hand it, cubes it, adds 3. How about a function that doubles what you put in, and then subtracts 10? Is that right? If I double what you put in, it's 2x, and then I said subtracts 10, right? So be careful of the difference between doubling and squaring. Tricked you, haha. All right, now there's all sorts of algebraic things we could do, right? What if I say this? I'm going to take something, whatever I have, plug it in. I'd like to square it and then add 1 and take that answer and divide it by 2. So I said I wanted to do what? Square it, add 1, and then take all of that and divide it by 2. So all of it over 2, right? And I can just, we could go all day, right, creating functions. What I'm trying to get you to see is this is the notation we use when we want to define a function, right? Let's do one more, or 2 more, sorry. What if I want to take something and whatever it is, I want to divide it into 3? How would I do that? Divide it into 3. 3 over x. So that'll take whatever I get, right? Whatever is given to it, the input, and it will try and divide it into 3. How about if I want to take the input and I want to take the square root of it? This all okay? No questions? Okay, now let's talk back again about domain. The domain was what? What was the definition of the domain? It's the inputs, right? It's the inputs. My question to you is, look at all these functions I have up here. Are there any functions up here that you have to be careful with? In other words, that you can't just plug anything you want into it. So let's take these one at a time. Let's look at the f of x equals x cubed plus 3. If I give you a number, any number, can you cube it? Sure. 0 times 0 times 0. Right? Would still give you 0. Well, that's right. There are some, but we need to figure out which of these functions actually we have to worry about. You can take any number you want and multiply it times itself 3 times, can't you? And then can't you always add 3 to anything? So would you agree that for the first one there highlighted, that I can give it anything I want? Its domain can be anything. Now let's look at the one top right. If I give that function any number, can I double it? So you can multiply any number times 2, right? And then you can subtract 10. No problems? How about the next one? Can I take any number and square it? Can I add 1 to it? Can I divide that by 2? No issues? How about this one? Can I take any number and divide it into 3? No. Which number can't I do? 0, right? Look at for this one here, x cannot be 0. If I try 0, I get 3 divided by 0, 2 divided by 0. It's not allowed, right? But every other number should work, shouldn't it? I go 3 over 1, 3 over -1, 3 over decimals. As long as I don't have 0 down there, I'm okay. So this is where we start to get into the idea of the domain. On all the yellow functions there, I could plug anything I wanted into it. On the bottom one here, the green one, you can't plug 0 in, but anything else is okay. And what about this last one? Can you take the square root of any number? Can you take the square root of 0? What's the square root of 4? 2, because 2 times 2 is 4, right? But the square root of 0 is 0, because 0 times 0 is 0. So you can take the square root of 0. You can take the square root of positive numbers, but you cannot take the square root of negative numbers. Then you get imaginary numbers, and we're not dealing with that at this point in time. So this right here, what we need to make sure is that the x we plug in has to be bigger than or equal to 0. Do you agree with that? That means everything bigger than 0, and you can plug 0 in, that's why it equals, but nothing less than 0. Now I want to scroll back up to the ones in yellow and talk about those domains. For the ones in yellow, we said there was no restrictions, right? It could be anything we want. So there's several ways to say anything you want. One way is to say, I'm going to say for this one, the domain, all real numbers. That's one way to say that, the domain of that function. Another way, my preferred way, I like this one, is a double struct capital R. Double struct capital R represents all real numbers. So that's just a very simple way of saying, hey, you can plug anything you want into that. And then the last one, and the one that you'll see a lot in your homework, is this one. This is an interval. And what that's saying is if you look at a number line, we're saying, and let's say the center of that number line is 0, negative infinity is all the way to the left, right? And positive infinity is all the way to the right. So by writing parentheses, negative infinity, comma, parentheses, parentheses, negative infinity, comma, infinity, parentheses, that means everything between negative infinity and infinity. Everything between them. So that means everything, right? That's the one that we're going to use the most, right there. And wouldn't the top two on the right also be all real numbers, right? These two, though, we would have some restrictions. Okay. You all right with this? So let's practice some of these now, some domain problems. Let's find the domains. Okay, problem A. Problem A. Let's call a function g of h equals square root of 5 minus 3h. What's the name of that function? What's the name of that function? G. What does g do? Well, it takes in a value of h, right? Whatever you give it, multiplies it by 3, takes that answer away from 5, and then takes the square root. And what I want to know is what can you not plug in? Or can you plug anything you want in? You got to be careful with the square root, right? What we know is that anytime you have a square root, that what's underneath it cannot be negative, right? We call the thing underneath the square root the radicand. Okay, I'm going to box it here. This right here, everything underneath the square root is called the radicand. What we need to make sure is that the radicand is bigger than or equal to 0. Agreed? As long as that's true, then we should be able to take the square root of it. And that right there is called a linear inequality. I forgot to mention to all of y'all, I told you last class that I had switched over to YouTube, right? And I put all these videos on YouTube. Well, I was in my office yesterday, and I ran across something I did in 2008. I did a college algebra class where what I did was I did videos that the students had to watch before they came to class, and then in class we did problems. And so I did the entire semester worth of like lectures on video. And so I found those, so I uploaded them all to YouTube. And so it's something called 1314 College Algebra Tech, TECH for like technology. Because back in 2008, that was like revolutionary to hand the students a package of CDs and say, watch all these videos, right? So that was my technology class. In there, they're listed out, each video is listed by what it covers. So I'm sure there's something in there saying linear inequalities, if you want to go back and review linear inequalities. I think there's 101 videos in that one little thing I did. So there's a lot of stuff there. To solve a linear inequality, all you have to do is isolate the variable. Right? Isolate the variable. Get it by itself on one side. So I'm going to subtract 3 on both sides, or not 3, subtract 5 on both sides. And when I do that, I should get negative 3h is greater than or equal to negative 5. Now what? Trying to get h by itself, right? Divide by negative 3. Who's going to earn 5 points on the quiz that they just took by telling me what I need to do, other than divide by 3? There you go. Who said that? There you go. Mr. Kosa, right? Anytime you have an inequality and you divide both sides of an inequality by a negative number, the inequality flips over. That's just part of what it takes when you solve linear inequalities. So when I divide through right now by negative 3 and negative 3 here, I have to keep in mind that this will flip. That only happens when you divide by a negative. Only when you divide by negative. If we had divided by positive 3, it would not flip. Okay? So let's see what we get here. Negative 3 over negative 3 is positive 1, so we get just h here. Now we flip the inequality. H must be less than or equal to negative 5 over negative 3 is positive 5 over 3. This is our domain. What is that saying? What is that answer saying? Now I understand it says h is less than or equal to 5/3, but like, tell me like in layman's terms, if you're trying to explain to someone what that answer represents in terms of our function, what is it saying to us? Go ahead, Sarah. Well, which one? Less than. So h, not x, right? H. So if we want this function to work, right, then it can't have negatives underneath the root. So whatever we feed the function has to be able to handle. This tells us that the only thing that will work are h values that are less than or equal to 5/3. Now, if you want, let's draw a number line just so we can kind of get an understanding of what this means. If this is a number line, if this is 5/3 right here, then I'm saying that whatever value we plug in has to be less than or equal to that. Means that it can be anything to the left of it, right? Anything over here forever. And it could also be 5/3 itself. So if I pick 5/3, plug it in, I should be okay. If I plug anything to the left of 5/3, I should be okay. But if I plug anything over to the right, something bad's going to happen. Yes, you can. That's why this is a little tricky. Because a lot of people think that because you have a square root, you can never plug a negative in. But you actually can. Because let's pick something to the left of 5/3, and let's pick a negative. How about negative 1? You all agree negative 1 lives over here somewhere? Yeah, negative 1 is way over there somewhere? According to our answer, we should be able to plug in negative 1. Well, let's try it. Come back up here. Let's plug negative 1 in. So I haven't really got to this yet, but This is the way we'd write it. That means we're replacing the h with -1, right? And now I rewrite the function, replacing my h with -1. Do you see what happens? Because I have the -3 in front of it, it becomes +3. And now you have 5 plus 3, which is 8. That's okay. Square root of 8, we can do it. I don't know what it is, but we can do it, right? So that's why we have to just be a little careful whenever there's something kind of complicated. When the radicand is somewhat complicated, we have to be a little bit careful about our answer. And don't get fixated on the idea of, oh, it can't be negative. It could be. Questions? All right. So how do I want you to write the answer on a quiz, on a test, on homework? Well, what I did here, okay, with the h and boxed it, that's okay. I mean, it's okay, but that's not what I would expect as a final answer. What I want is interval notation. Interval notation is working off of this number line. What you're saying is that you want everything to the left of 5/3 forever, right? Forever? And then all the way up to 5/3 and stop. So how would you read this from left to right, like a book? How do you say forever that way? Negative though, right? Negative infinity. So I would say, I'm going to put it right underneath this answer. Negative infinity, comma, reading to the right, where do I stop? At 5/3, so 5/3. That tells you so far, pretty much it's everything between there. Now you have to use either brackets or parentheses on the two sides. And what's the difference between a bracket and a parenthesis? Anyone that did intervals before? Parenthesis means you go all the way up to that number, but you don't ever get to that number. Bracket means you actually can get to that number and choose that number. Let me just write it down, then I'll explain it. I want to be able to go to 5/3, right? It's okay to have 5/3. That was because I had the little equals in there. See that little equals? That means that it's okay to equal 5/3. So since it's okay to equal 5/3, I put a bracket on the 5/3. Now, when it comes to infinity, positive or negative, you always put parentheses. And the reason why is because infinity is not a number. You can never get to infinity. So you can't bracket it and say, oh, stop when you get to infinity, you know? So the 5/3, though, we can get up to it and stop. Now, I just want to show you the difference here. If I had written this, how is this different? With parentheses there. So that means I can go all the way up to 5/3, but I can't use 5/3. And this is kind of a weird concept, because again, if we get our number line and I put 5/3 there, I can get a number pretty close to 5/3. See, I do with the dot, and I can get even closer, and even closer, and even closer, and even closer. And the way that the number system works is that there is an infinite number of numbers there. Like you can always get closer to 5/3 without getting there by just going halfway, right? And then once you're there, go half again, and then half again. You'll never run out of numbers. So by using the parenthesis, we're saying you can go all the way, keep going as close as you want, but just never plug in the 5/3, because that'll cause problems. Y'all kind of see the difference? All right. You're looking too comfortable. You look like you need a lazy boy, like a recliner or something. Go do some jumping jacks in the hallway, if you need to. All right, next one. Sorry, part B. This is all the same thing. Find the domain. So I'll go back to traditional f of x equals, let's do another square root problem. So what do you see as a potential issue here? we've got a square root, right? The square root tells us we cannot have what's underneath it be negative, right? So it's just like the other problem. But there's one other thing that we can't have happen here. We can't have the whole bottom equal what? 0. Or else then you have division by 0. So there's almost like two problems in one here. Do you see that? So there's two things. First, the 5 minus x must be greater than or equal to 0. Y'all agree with that? But the second issue is that the square root of 5 minus x can't be 0. Do you see the difference between those two and where they came from? First one is, oh, I'm looking at the square root. I'm looking at the radicand. It can't be negative. The second one's saying, hey, but the whole thing is a fraction. I can't have division by 0. So we have to solve both of these and figure out what comes of it, okay? So let's look at the first one. That's a linear inequality, right? Now, last time I moved the 5 over and we had to divide through and flip the sign. With this one, how about I do this instead? How about adding x to both sides? Is that okay? What do you get? 5 must be greater than or equal to x. You could also write it this way. That's the same thing, right? Because the arrow's pointing to the x in both of those. Now I'm going to go ahead and I'm going to draw a number line here. Here's 5. And I'm saying that I can be what? Or the answers, the only things that'll work must be what? To the left or right of 5? To the right. So if I put an x over here, is that x bigger than 5 or smaller? That x is bigger, right? What does this say? X must be what? Smaller than 5. So it's actually everything to the left of 5. So I'm going to do it this way. It's everything this way, right? But can it be 5? According to this, it can be 5, right? So what I'm going to do is I'm going to put a dot here, and I'm going to make it a solid dot. If I ever get to the point where I don't want 5, I would put an open circle. All right? Any questions on that part? Yes? I didn't flip. You mean from the box one to the one above? I didn't flip the sign. I changed everything. Like I flipped the entire thing over. See, the top one says 5 is bigger than or equal to x, right? The bottom one says x is less than or equal to 5. They say the same thing. It's just that most people find it easier to work with the second one than the first one. It's really your preference. What about this other equation, number 2? This is called a square root equation. And guess what? That's something that you should have seen at some point. There's a whole set of steps on how to solve square root equations. Let's see if this rings a bell. I know my 0303 students, this will ring a bell. It should. Unless it was a really good summer. Real good summer. Right? To solve a square root equation, you isolate the root. Once you isolate the root, you square both sides. Then you repeat the process if necessary. And then solve the remaining equation. Maybe not. So take a look at that. What I'm going to do here is I'm going to square both sides. Okay, I'm going to square both sides. Now, why do we square both sides? It takes away the square root. Well, the good news is we just have 5 minus x. Now, I'm working with this saying not equals 0. Okay, be careful. Make sure you keep that there. And the right side, 0 squared is 0. Now just move the x over to the other side by adding it again. And what you get is 5 cannot equal x, or x cannot equal 5. So if I look at a number line, here's 5. I'm saying I can't be 5, so I'm going to leave an open circle. But I can be anything else. Do y'all see that? Now, these are two completely separate problems within the bigger problem. The one on the left is saying, look, if this function is going to work, you can only plug in stuff, what? To the left of 5 and 5 itself. This one's saying, no matter what you do, just don't pick 5, right? Now what we have to do is combine those two together into a final answer. So what you're looking at is, what do these both have in common? What do they share? Everything to the left of 5. Everything to the left of 5. Now, how about 5 itself? No. This one says yes, that's okay. This one says, hell no, you can't have 5. Why can't we take stuff to the right? This one says to the right's okay. That one says to the right's not okay. So you got to do what they have in common. They both have to include it. So the stuff to the left of the 5, they both have. So our final answer is this. Our final answer is a combination of these two. It's 5, don't include 5, everything to the left of 5. And how do we write that as an interval? How do we say everything to the left forever? Negative infinity, comma, where do we stop? At 5. But a parenthesis on the 5, that tells you go all the way up to 5, but never be 5. And then on the left side, parentheses always on infinity. That's what we're looking for. So with this function, can I plug in 10? We should have major problems if we try plugging in 10. Can I plug in negative 30? Yes. Okay. But it requires some work to know this now, right? Next one. C. How about if I write P equals Q plus 7 over Q squared. Whoa. Not sure what happened. Q squared minus 3Q minus 18. Now I want you to notice something right away here. This thing is not given to us in functional notation. In other words, they should have written P as P of Q, like this, to let you know that the input is Q, right? But if they don't write it, it's just understood that P can be determined if I give you Q. Do y'all agree with that? If I give you a value for Q right now, you can tell me what P is? Okay, so P is a function of Q without writing it. See any issues here? Talking about domains still. You see any square roots? No. So square roots are big red flags for us, right? That's right, but it's a fraction. So the bottom can't be 0. Right? The bottom can't be 0. That's the only thing we have to worry about. This denominator right here cannot be 0. So I'm going to go ahead and write that down. Q squared minus 3Q minus 18 cannot be 0. And what type of equation is that? Not linear, it's quadratic. And now the question becomes for you, do I remember how to solve quadratic equations? AC method or Guess and check, or we've been through this, right? Quadratic formula, right? Now, I'm going to go ahead and do guess and check or AC method. I'm not even going to show it. I'm just going to go to the factored form of the left side now. So the left side should factor to be q minus 6, q plus 3. Does not equal 0, right? That's what I want. I want for this to not be 0. Once you factor, don't you set each factor to 0? Or in this case, to not 0? So I'm going to take q minus 6 and say I don't want that to be 0. I take q plus 3 and I say I don't want that to be 0. And then solve each of these by just moving the constants to the other side. So we have q is not equal to 6, right? And q is not equal to what? Negative 3. Lesson. Questions on this? You okay? All right. Then, how do we write our answer in interval notation? How do we write everything except 6 and negative 3? Well, my recommendation is to draw a number line. Write out the two things you can't have and make sure you put them in the right order. So negative 3 is somewhere. 6 is to the right of it, correct? Okay. Now I do not want those, so I'm going to put open circles there. But anything else works, right? So anything to the left of negative 3, anything to the right of negative 3, all the way to 6, and then anything from 6 on forever. So it's basically this, and this, right? All that stuff, but not those points. So this is kind of weird because what we need to do is start way out there, which is what? Negative infinity, all the way up to what? Negative 3. And we have to make sure we don't do negative 3. So we're going to have to put parentheses on it, right? And then we want to say from negative 3 all the way to 6. And then we want to say from 6 all the way to infinity. So watch the way I write this. I'm going to put them right underneath each of the sections. This left section, negative infinity to negative 3, parenthesis. Agree? Now, underneath the other section, negative 3 to 6, parenthesis, on both. Why are there parentheses on both in the middle one? You don't want to get to negative 3, right? You don't want to get to 6. You want to make sure you don't include those. And then how do I say from 6 on? 6 to infinity, parenthesis 6, infinity. Yeah? Yeah, we have to combine these, okay? So we have a standard mathematical symbol that we use to connect intervals together. And it's a capital U. It's called the union symbol. So between each of these intervals, we put a U. All that means is every answer over there, all the answers on the left side, throw them into a pot. Unioned with the ones in the middle, throw those into the pot. And then union with all those, throw those into the pot. That all together, union, is your answer. See, we can't use addition because intervals aren't numbers. You can't add, like you can add 3 and 4, but you can't add an interval to another interval. It doesn't make sense. So we use a union symbol instead. That's your answer. I apologize for the joy you're getting right now. Some of you seem so elated. I'm afraid, you're going to have to go calm down after this class. It's all right. We're going to be good. There's a lot of things today that are important. Domain is important, but also this whole interval notation, we're going to spend a lot of time with this. All right? Next class, we're going to really get into it. One more example, and then I'm going to let you work on a couple until we run out of time today. I'm going to count today as a quiz grade just for attendance and for participation at the end. So, all right? Let me see. Let me get to my example. I'm going to do this one quickly. This is what? D, E? Where am I? D? Okay, what about f of t equals the square root of 9 over 3 minus 2t. All right, so I said I'm going to move quickly. The first thing I notice is that I have a fraction, and that possibly that could be 0, which would be bad, right? So I say 3 minus 2t, that can't be 0, or else I'm in trouble, right? And I add 2t to both sides, and I divide by 2. And so what I know so far is that whatever I do, I should not let t be 3 halves. That's going to cause a major problem. Bless you. Any questions there? But that's not the only issue I have, is it? I have a square root, don't I? So I need to look at something else here. What I need to make sure with the square root is that the entire radicand, everything in there, has to be what? 9 over 3 minus 2t must turn out to be greater than or equal to 0. Do y'all agree with that? That has to be greater than or equal to 0. This is tricky. Because this is an inequality, but it's not linear, it's not quadratic. The left side is a rational function. Or, yeah, it's a rational expression. So how can I figure out when that's bigger than or equal to 0? It's tricky. Yeah, your instinct might be to do this. Multiply both sides, right, by 3 minus 2t. Now, you don't necessarily need to write this, okay? But that might be your instinct, right? Clear your fractions. But what happens is this. These cancel, and this side is, what, times 0? It's gone. So your left side is 9, and the right side is greater than or equal to 0. 9 is greater than or equal to 0. Good. I agree. Big deal. See, it doesn't do anything. So what you do to solve something like this is as follows. You take the denominator and you set it equal to 0. All right? And we already did that on the problem to the left, right? We set that equal to 0. Well, not equal to 0. We already know this is going to give us t equals 3 halves, right? Then what we do is we just plot that 3 halves on a number line. And this splits our number line into 2 sections. And I will pick any number I want on each side. Just pick a number. Anything to the left of 3 halves. Pick something nice. What's to the left of 3 halves? That's to the right. To the left. -2, even nicer. Even nicer. Even nicer. 0. How about 0? 0 to the left of that, right? And the thing is about 0 is that if I take 0, what would I get if I plug 0 into this expression right here? I get 9 over, what? 3 minus 2 times 0, which is 9 over 3, which is 3, right? So I need to write the rest of this down. I'm going to scroll up. If I plug 0 in, I get that whole thing up there becomes 3 is what? 3 is greater than or equal to 0, right? Is that true? Okay, so I'm going to put a check mark over here. Now I want you to pick something to the right of 3 halves, like 2. Right, 3 halves is 1.5. So I'm going to pick 2. And now plug 2 into this thing up here. I think I'll use a different color. I think I'll use for over here 2. I take this whole thing again, and now I plug it in. 9 over 3 minus 2 times 2. Is that greater than or equal to 0? Isn't the denominator 3 minus 4? It's 3 minus 4. Negative 1? So isn't this 9 over negative 1? Is that negative 9? Is negative 9 bigger than or equal to 0? No. That means this side doesn't work. So the only thing that does work is what? The stuff to the left of 3/2. So everything over here works. Okay? This is tricky, that's why I'm showing you this problem. I'm ready to get a final answer, and I'll try and fit it all on one screen. Here's my final answer. What does the black side over there tell us? 3/2. Oh wait, why did I put negative? T cannot be 3/2, so I don't want to include that, right? What does the one on the right tell me? Everything to the left of 3/2, right? Which is this. So how do I write that as an interval? Three halves, parentheses. That's our answer. Tricky. I think that's a good place for us to stop. And we still have more stuff to do in this section. What do you think? Y'all ready to stop? Y'all want to practice a couple on your own? I'll give you 2 to practice. So find the domain. Find the domain. F of x equals 2 over square root 5x minus 1. Second one, g of s. Oh, I better not use s. A lot of people's s's look like 5s. G of t equals 2t plus 1 over t squared minus t minus 12. All right, for both of those, find the domain in interval notation. You have 10 minutes. Well, not quite. More like 8. I'm going to write the homework assignment down below this. I suggest you do the homework. All right, your homework assignments here. I'm going to pause the video or stop the video real quick.